Reciprocal trigonometric ratios. We talked about this a couple days ago in class, and I want to go into more detail about today. As we've said, SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent equals opposite over adjacent. I got a triangle here. A, B are the legs. It's a right triangle. You can see the right angle in there. And then C is hypotenuse. My sine is A over C. So as we're doing angle A, the opposite of A is the little a over C. Cosine is adjacent to the angle A, B over C. And then the tangent is A over B. Now, I'm just going to do the reciprocals of these. Instead of A over C, we'll have C over A. Instead of B over C, we'll have C over A. Instead of A over B, we have B over A. These are the reciprocal trigonometric ratios. All we're doing is flipping what the ratio is, the sine, which is A over C, is now C over A. The cosine is B over C. I mean, C over, yeah, is B over C. So the inverse, that's C over B. And then tangent, which is A over B, is now B over A. These are called our inverse trigonometric ratios. And for sine, instead of A over C, it's called the cosecant, which is simply C over A. It's the hypotenuse over the opposite angle. Here's my angle A still. And I'm going to do the hypotenuse over the opposite instead of opposite over hypotenuse. My cosine would be B over C, which is my B here over my hypotenuse. And the secant is the inverse of that. And that simply, let me erase some of this here. And that simply means I'm going to take the hypotenuse in the numerator and my adjacent for the angle A, which is B, so it'd be C over B, for that new ratio. And then the tangent, instead of opposite over adjacent, is going to be adjacent over opposite. Now looking at angle A, the opposite of angle A is that line A, and adjacent's B, but now it's going to be B over A, the adjacent over the opposite. And as I said here, the simplest way to figure this out is the cosecant, reciprocal of the sine. Cosecant is 1 over sine A. Secant is 1 over cosine A. And cotangent is the reciprocal of 1 over tangent. And I got some simple ratios here, and we're not going to go beyond the ratios for this, because unless we're doing more advanced trigonometric functions, we're just going to keep, I just want to be aware of what these are, and we can figure these out. We do the inverse, go back to see what the angle is. I got a triangle here. It's a right triangle. You can see the right angle there, at angle B. One leg is 8, the other leg is 15, and hypotenuse is 17. So my cosecant is opposite, it's hypotenuse over opposite. 17 is my hypotenuse. This is for angle C, which is right here. And the opposite is 15. So it'd be 17 over 15 right here. And then if I go back and I look at, figure out the secant, which is the hypotenuse over the adjacent. And that's going to be, again, my hypotenuse is 17. My adjacent to C, here at angle C, is 8. So it'd be 17 over 8. And then my cotangent is going to be adjacent over opposite. So when I go back here, I've got the adjacent for C is 8. The opposite over the angle C is 15, so it'll be 8 over 15. Another one here, my cosecant is hypotenuse over opposite, which is, here's my hypotenuse, 5. And that's going to be here as well for the secant, 5 here, 5 here is my hypotenuse. And then my opposite for angle X, here's angle X right here. The opposite is 3. So it's 3. The adjacent for X angle X is right here, 4. That's 4. And then it's adjacent over opposite. My opposite, I said, is 3. That's in the bottom here. My adjacent, which is my numerator, which is top here, is 4. Another right triangle here. And I want to know the angle. I got C here is actually should be cosecant of opposite would be R. No. Forgive me for this. I'm going to fix it right now. There's R, and there's R. So cosecant is hypotenuse. Here's my hypotenuse, which is 25. So that'll be there, and let's put it in for my secant as well. And the opposite of R is 7. Here's R, which I fixed. There's the opposite of it, 7. That goes here. So it's 25 over 7. And then my adjacent to R is 24, right here. So it's right there, 24. And then adjacent over opposite, my adjacent we just learned is 24. My opposite, as we learned earlier, is 7. 24 over 7. Now, one thing I want to prove here is we're looking at isosceles triangle here. And remember, if it's a right triangle and one of the other angles is 45 degrees, well, then the other one's 45 degrees. And we have some interesting ratios going on here. Traditionally, we say if one leg is A and the other leg is A, then the hypotenuse is A times the square root of 2. Well, let's take a look at this here. My cosecant is hypotenuse over opposite. If it's A over 2 for the hypotenuse, which is right here, and my other side is, one of the legs is A, it really doesn't matter at this point because they're both the same. A over 2 over A, the A, 2 over A, the A's cancel out, and I'm left with the square root of 2. So the ratio basically is 1 to 1, the square root of 2. This is also what we do with the 30, 60, 90 right triangle. Again, these proportions remain the same. We'll be seeing more of this with the trigonometric functions, the 45s, the 30s, and 60s, and all their various attributes. Remember, the side opposite of 30, we have a ratio of 1 for one leg. The other leg's square root of 3, and then the hypotenuse is always 2. These are the ratios to each other for a 30, 60, 90 triangle. And let's look at this. If we do the cosecant, hypotenuse over the opposite, it's 2. Here's my height. I'm looking at angle for 60 degrees. Here's 60 degrees right here. And then this should be, let's see here, 30 degrees. 2 is my hypotenuse. So that's going to be here and here. And then I have my opposite of this, which is, that's the opposite angle, and that should be angle B, and I apologize again. B and B, I don't know where I got the W. Which probably a previous slide. Anyhow, so if my hypotenuse is 2, and then my adjacent is 1 next to the 60 degrees, 2 over 1 is simply 2. Then I go tangent opposite over adjacent. And here's my opposite square. I'm sorry, that is tangent. Adjacent over opposite is cotangent, and that is going to be 1. Here's my adjacent, angle 60 degrees. Here's my opposite, which is square root of 3. So this is, we're going to see these ratios, and that's how these ratios are formed, basically looking at the inverse trigonometric functions.